Good morning to everyone. My name is Krishmeet Singh. Today I will discuss about the branch and bound the knapsack problem. First, discuss about what is branch and bound. It is a systematic algorithm designed for solving the best possible solution or a optimal solution in a branch and bound problem. It helps us to explore all the solution space by dividing the problem into smaller sub-problem. Means that whether we have include the item or not include the item, and help us to find the upper bound in the optimal solution, like best solution. And what are the key concepts of the branch and bound? Key concept first, branching. I will tell branching means we have to include the item or exclude the item. Means that dividing the problem into smaller sub-problem to help us to find the best optimal solution. And the bounding means to help us to calculate the upper bound for each problem using the linear programming formula to find the best optimal solution. And tuning means whether we have to include the item, not include the item means that if the weight is exceeding the capacity or not exceeding, if it's exceeding the capacity, we have to do not consider and we have to discard the that problem. Branching and bounding in the knapsack, that is discussed. Branching means that in the knapsack, whether we have to, in making the decision that whether we have to include the item or exclude the item in the knapsack, means it helps us to create a state space rate that we have to with or without the item. But with means including the item test, we have to add a profit and the weight of the current to the current total. Means that if we select the first item, then we have to consider the its weight and the profit. Excluding the item means keep the current total unchanged without considering the weight and the profit of the first item. And bounding means to help us to calculate the upper bound for to maximize the value that can help us to achieve the optimal solution in the problem. And it can be done by using the linear programming formula, where the fraction solution are also allowed. Means that we have to consider weight by profit by weight that help us to calculate the upper bound. And if the bound of the sub problem is less than the current total, like current upper bound, then we have to discard that branch. So, what is a problem statement in the branch and bound knapsack problem? Let us know the formal definition of the knapsack problem like that we are giving the set of n items and each with the profit and the weight of the that item that we have selected, and also giving the maximum capacity of the knapsack, that is W. And objectively, we have to find the total maximum total value items in the knapsack, because in the branch amount knapsack we have to consider the maximum capacity. It should be equal to or less than the capacity without exceeding the weight. Means it should not be greater than the maximum capacity in the knapsack. And in the branch and bound knapsack we have to calculate the upper bound calculation also for each node. Upper bound calculation help us to find the best optimal solution in the branch and bound knapsack. Branch and bound assessment is done by using the state space tree also. Then then we have to calculate the upper bound calculation. If the weight is less than the upper bound, then can calculate it using this formula, that is current value plus the maximum capacity, that is weight I consider, and the weight of the next item and the value of the next item that we have considered. So I consider the example, that is problem parameter, that I consider the four objects and the weights and the profit. And the weights are 4, 7, and 5 and 3. And the profits is 40, 42, 25, and 12. These are the weights and the objects that I consider. And I consider the capacity of the knapsack, that is m equals to 10. And first we have to calculate the fractions of the profit and the weight that we using this formula, that is 40 by 4 is 10, and 42 by 7 6, 25 by 5 5, and 23 by 7. So then we have to arrange in a non in a descending order for the inequality check. 10 is less than equal to or greater than 6, 6 is greater than 5, and 5 is greater than 4. So in previous we have calculated the fractions, that profit by weight, and also in this we have calculated the upper bound calculation. So this is a formula for you finding the upper bound, that is current weight, weight minus current weight, and the weight of the next item into the value of the next item, means profit of the next item. First, initially we don't have any weight or a profit in the upper bound. Then we have to consider the value of the inequality first, doing that is 10 6 5. We have done by using the profit by weight, that is 10 0, and which is 100. This is the initial upper bound in the branch and bound national problem when no items are selected. After selecting the first item means that n equals to n, that is profit 40 and weight equals to 4. Then we have to put the values these into this upper bound formula. And after the calculation we got the value is 76. And we have to doing the without selecting. This is a branching that I told you about, that is including or excluding the item in the branch and bound. That is without selecting the first one means no profit, no weight. We have to select in the branch and bound. That is 0, 0. And when these values are remains, then the calculation that 10 into 6 we have the value 60. After selecting the second item, that is weight is initially it is 4 in the after selecting 4. Then the weight of the second item is 7. 7 plus 4 its weight is 11, which is not feasible because total capacity is 10. That is I discussed now. Weight should be equal to 10 or less than 10. It should not be greater than the 10, which is not feasible. Then we cannot consider this second item. Similarly, compute upper bounds for all other items. So with the help of a state space tree, we can find the optimal solution in the branch and bound knapsack problem. So in the previous, we have calculated the initial bound that is weight is 0, profit is 0, and the upper bound is 100. And we have also calculate the without with selecting the first item and without selecting the first item. That is weight is 70, upper bound is 76 and upper bound is 60. Why it is intended to know that why I calculated. Then after selecting the second item, that is weight is 11, which is greater than the maximum capacity of the knapsack, which is not feasible. So we have not considered this. And the without selecting that weight and profit should be, but the fractional problem is same because of, it should be the value of the profit of the next item by weight of the next item. That is weight is 40. Then for the using the upper bound calculation, upper bound formula, we got the upper bound is 70. And after with selecting the third item and without selecting, first we have to consider with selecting the third item. That is weight is 5 and initially we have 4. 4 plus 5 is 9. It is less than 9, that it should be considered. And the profit is 40 and the profit of the third item is 25. 40 plus 25 we got the 61. Then using the upper bound formula we got the upper bound value is 69. Without selecting the weightage should be same and but the value of the fraction is same, that is 61. We need to know that by 10. And then next we have to select the fourth items in the knapsack. That is initially we have 9, then 9 plus 4, 9 plus 3 value is 12 because it should be less than 10 or equal to 10. It is greater than 10, so it's we have to discard this the value that is proving. And without setting that weight and profit in this is same, and this is the last problem because just we have to know problem then what the value is up around 65. And this is the find the optimal solution using the state space. Why it is optimal solution? Because we got the value because the weights are under the maximum capacity, that is 10. And why it is intended to note that the 1660 because the 65 is greater than 64 or 61. That's the value. And the item we have selected the 1 and 3, that is weight 4 plus 5, that is 9, and profit is 69. The optimal solution is 65 we got. What are the applications of branch and bound? First, we will discuss that is natural, and we have discussed this help us to find the optimal solution using the branching and bounding, that including the atoms, excluding the atoms, and finding the upper bound and the to maximize the value. And in the second, we have traveling salesman problem. That's if we are moving to the city, that there are two routes. Is one is longest and other one is shorter, which will be selected, which help us to find the shortest spots that we have to reach that city. And integral problem means to solve the optimization problem required to be commonly used in resource allocation, networking, or network design maybe. And job scheduling means optimize the schedules of the job that to minimize the completion time, like minimum the time or other criteria. So, and in coloring, we can use this branch around when non two adjacent vertices share the same color and to minimize the number of color in the graph. What are the advantages and disadvantages of branch and bound for the knapsack problem that we discussed? And first advantage, it guaranteed gives us the optimal solution using the upper bound formula and using the branching and bounding in the knapsack problem. And systematical approach, it's explore all the solutions like Italian branching with or without excluding the item in a state space tree. And pruning is help you to discard that if the weight is capacity weight is greater than the capacity, then we have to discard the that branch or reducing the such space. Disadvantage means it's intensely used for larger intents. Means that this method is slow because if we have number of items like because I consider only four objects in for the problem parameter. But if we have the 10 items, then we have to create a very huge facility that will lead to longer time to compute the best optimal solution in that complexity means it should be complex because it requires careful design, bounding functions, and pruning means branching and bounding. It should be done correctly, and pruning means discarding the items in the absent. So hopefully, I hope you will understand the branch and bound absent problem. That what are its let us summarize that in which we have doing the branching and bounding and pruning in the state space tree without or with setting the selecting item and we have to calculate the upper bound in the branch and bound absent. Thank you.